Session 6. Energy stores. What is the equation to calculate the change in gravitational potential energy? So the change in GPE equals m times by, so mass times by gravity times by the change in the height. A 1 kilogram book is lifted, so that's the mass. It's lifted by 2 meters, so that's our delta H. What is the change in gravitational potential energy? So GPE equals question mark. Tells us gravity is 10 newtons per kilogram on Earth. So the change in the GPE equals mass, so 1.5 times by the height times by gravity, 10. So that's just 30, and that'll be joules. What is the equation to calculate kinetic energy? Kinetic energy equals a half mv squared, half times by mass times by velocity squared. A 60 kilogram person, so that's the mass, runs at 3 meters a second, that's the velocity. How much kinetic energy do they store? Kinetic energy do a half times by their mass times by their velocity squared. Remember to square the velocity first. So 3 times by 3 is 9, times it by 60, and then half it. 270 joules. Copy a Sankey diagram into the booklet. So a Sankey diagram lets people know how much energy's gone in and where the energy goes to. The useful energy goes along the top, the wasted energy goes along the bottom, and the total energy in goes in here. The width of the arrow represents the width, how much energy there is. So 1, 2, 3, 4, 5 wide there, which means that this will just be 1 wide, and across here will be 4. So those 4 plus that 1 equals them 5. If it was percentage, that would be 100% going in, it always is, and that would be 20% coming out in this case because it's just 1 of the 5. Each one would represent 20 obviously, and this is 80% getting wasted. So that could typically be for a bulb, only 20% useful energy coming out and 80% wasted. As heat, the useful would obviously be light. So there's just a typical example. List the different stores of energy below. Chemical energy, kinetic energy, thermal energy, strain energy, elastic potential energy, gravitational potential energy, and nuclear energy. What is the law of conservation of energy? Energy in equals energy out. Law of conservation of energy. Energy can't be created or destroyed. It simply gets turned into different forms. Draw an energy transfer diagram for an object projected upwards or up a slope. So it'll be going fast at first. So kinetic energy will be getting turned into gravitational potential energy as it goes higher. Move an object hitting an obstacle. So kinetic energy at first because it's moving. Hitting an obstacle, you're going to get sound and heat. An object being accelerated by a constant force. If it's accelerating, it'll end up with kinetic energy. Constant force, well, if it's a man or a woman providing the force, it would be chemical energy from food. Vehicle slowing down, kinetic energy gets turned into heat energy in the brakes and on the wheels. Bringing water to a boil with an electric kettle, that would be electrical energy getting turned into heat energy. What does a closed system mean? It means nothing can get in or out, in particular to do with mass or energy. How does this link to the law of conservation of energy? Well, it means that energy can't get into the system and it can't leave the system. So whatever is in there at the start will be in there at the end. A TV wastes thermal energy. What effect does this have on the surroundings? It makes the surroundings get hot, because thermal energy is just heat energy. Explain what dissipated means. It means spread out, perhaps lost to the surroundings. Give an example of energy being dissipated. Well, that telly. The heat energy is getting dissipated to the surroundings. Maria says that all energy eventually becomes dissipated. Is she correct? Explain. Well, all energy does eventually become heat, and heat eventually gets spread out to the surroundings. So yes, she's correct. Explain how lubricating a machine reduces the wasted energy. It makes more useful energy. So if you've got more useful energy, then you've got less wasted energy. Explain how loft insulation reduces the amount of wasted energy. Well, normally the energy will be heat and hot air rises. So if you've insulated your ceiling, insulated your roof, then you won't lose as much heat through the roof. It'll stay inside your house. Here are some forms of energy: chemical, elastic, electrical, heat, kinetic, light, nuclear, sound. Use words from the box to complete the table. Each word may be used once, more than once, or not at all. So the first one's been done for us. The device was an electric motor. Energy transferred from electrical energy to power it, and kinetic energy is what comes out. A bow and arrow, elastic potential energy goes in, kinetic energy comes out because the arrow flies, and it would also be gravitational potential energy because it'll not be on the floor, it'll be flying through the sky. Electrical kettle is electrical energy, gets turned into heat energy, probably in sound because kettles can be noisy. Microphone, sound energy goes in, that's you talking, and then it gets turned into electrical energy, comes out. The microphone could be plugged into a speaker, in which case the electrical energy would then get turned into sound energy again. And that's that. A little bit of speed physics there. Use it the night before your exam. Get some last minute revision in. Hey! And that's session 6 done. Thank you very much. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now. Work hard and be nice.